Before we talk about column level encryption, let's talk about service master key, database master keys. What I have here, I have three operating systems. This is my domain controller, and this is my source server, and this is my target server. I have SQL Server installed on these servers, source and target servers. So I can access these servers directly from this VirtualBox options, but I can use remote desktop connection manager. So this is how I RDP to the servers. Let's connect to the servers. This is my source server. I named it accordingly just for the sake of convenience. I have nothing installed. I haven't created any user databases here. So let's go through this server. In fact, I have created some catalog views just to browse the data. So copy this. So these are the catalog views which are related to the encryption. I just select from all the catalog views just to show you what are the things that gets created when you install. So when you install, you will see service master key with the service master key ID 102. So this is what you see. Service master key is automatically this symmetric key. It is, if you select this one, you will see the service master key. So that tells me that service master key is a symmetric key. So you will see the symmetric key, service master key, key ID is 102. If you create database and then create the database master key, you will see the symmetric key ID for the database master key as 101. But for the service master key, you will see 102 and then the modify date, create date, and whatever the default encryption algorithm that SQL Server uses to create the service master key, AES 256. But if you are installing SQL Server 2005 or 2008, probably it might be using a different encryption. So when you upgrade your databases from 2005 or 2008 to latest versions, 2012, 16, things like that, then you have to regenerate the service master key in order to use the new encryption defaults. So by default, it uses AES 256 algorithm. This is service master key GUID. This is what it uses to encrypt. So here you can see this service master key encryptions. So you can see that here the service master key is encrypted by two things here. So what are these two records? I'm just guessing. This is encrypted by master key and this is encrypted by master key. So if you look at from this diagram, encryption key diagram, the service master key is encrypted by Windows level, right? It encrypted by Windows DP API. And then there is another record. I guess one record might be encrypted by the DP API, other record might be the service account. So what happens here is when you install the SQL Server instance, service master key gets created and it is protected by DP API as well as it is encrypted by the service account. The reason for the service account is for example, in case of cluster, you fail over from one node to other node, right? The DP API is strictly based on the machine account, the server. In case of two node cluster or three node cluster, whatever the cluster, you fail over from one server to other server, then the service master key, if you strictly go by Windows level, just encrypted by DP API, nothing else, the database, that instance fail over to other node, then it cannot decrypt that SMK. So basically, so everything else will fall actually, right? So that's why you need to have a service master key protected by Windows account, DP API, as well as a service account. So if you have either one of these, then the service master key will be automatically open. In case of clusters, you can see that SQL instance fail over from one node to other node. You don't have the machine. The machine will be different because the database is same, but it will have different machine account. It cannot open. So that's why you need to have service master key. Not only that, when you are setting up the log shipping or change in data encryption, database encryption, things like that, you probably might want to take service master key backup and then restore it on the different server. So if you are using the same service account, then probably you can open the service master key. For example, your server got crashed and you have the master database and you know the service account, but you can't restore that particular server. Then what you can do is you can just take the database files and restore it on different server and use the same service account to open the service master key, and then you can open every other database master key and then whatever the key is under beneath that database master key. Okay, so basically the point you need to remember, service master key is protected, is encrypted by two keys. One is the machine, the server that is sitting on, and then the service account. If you have either one of these, then you can open the service master key. So that is what these key encryptions, these two records, I think. But it doesn't say clearly it is protected by service account or things like that. But I don't see any description in Microsoft manual about these two. Probably I may not be looking, or I'm not finding it. So I'm just leaving it to you. So these are the two encryption keys that you can use to decrypt the service master key. Okay, so you can see that there is nothing else. So every other catalog views, there is no records here. Okay, same thing, you just copy these catalog views, go to the target server, and then execute. You will see the same thing. This is my target server. I installed SQL 2017 on both the servers. You can see the version here, and by default it has SMK 102, the service master key ID, and then two keys. There are two encryption keys for the service master key. Now let's talk about the DMKs. So DMK, when you create a database, you will have to create the DMK. So let's create a database. Before we create database, let's talk about let's encrypt the column. When you encrypt the column, then you got to use you have to create the DMK, SMK, not SMK, DMK, whatever the certificate stuff like that. So let's encrypt the column. Okay, so how you are going to encrypt the column? First, you need to create the DMK, database master key. When you create database, you have to manually create the DMK and then create the certificate encrypted by DMK, and then create the symmetry key encrypted by certificate, and then finally you have to use the encrypt by key encryption function to encrypt the data based on the symmetry key. This is the sequence generally you follow to encrypt the column. Okay, let's copy this code and I'll show you step by step. Okay, let's create the database. All right. So the first step is, this is how you create the database master key. This is the first key you create. Create master key encryption by password. The reason why you have to say password, you must have to say password. So here you are creating database master key by password, and by default it is encrypted by SMK. So the database master key, you can decrypt the database master key based on if you have a password, or if there is SMK linked to the DMK, then the master key will be automatically open. Okay, so let's create the DMK. I'll show you. Here I just created the DMK, create database master key encrypted by password. So if I execute these queries, let's not execute from the master database. Open a new query window, select the test database, execute. Here you can see a database master key, symmetry key ID is 101. Okay, so why 101? I don't know. You got to remember it's 101. 101 means DMK, 102 is SMK. By default, AES 256. Can you change it? I don't know. You have to look into the database manual to see if you can specify a different algorithm for your DMK. By default, it is AES256, and then you have the create date and then GUID. Okay, so there is nothing else for DMK, and it is encrypted by two keys. We specified this DMK database master key by password, right? So that is what it says. It is protected by password, and it is also protected by service master key. Two keys, right? If you know the password, you can open the database master key, or if SMK is linked with DMK. See, right now I have created the database. I have created the database master key, right? So it automatically links. So what is that links? Let me show you what it is. Here you have SMK and DMK, database master key, the server master key. It gets created when you install the SQL Server instance, and it gets created when you manually create DMK. Okay, it is protected by SMK and password, right? So when protected by SMK and password, so when it is protected by SMK, that means there is a link that there is a record in SMK and there is a record in DMK. Okay, it has to be same or something. Okay, when you encrypt DMK, that means you don't say add SMK encryption for DMK, but when you create a DMK, it automatically creates two records, one record in master database, one record in user database. That way they both are same. There are some records that gets created in master database, probably in one of the internal database, and then there is some information recorded in user database. And if those values are same, that means this SMK automatically opens DMK. You don't need to open the DMK. Basically, you have to open all the related keys in order to encrypt the data. But how are you going to open the DMK? The DMK, it automatically opens if this information and this information is properly linked. How it is linked and which table has this information? It's like SID information for login and then user database. You can think of like that. If they have proper SID, then it automatically opens, right? Otherwise, the user will be orphan user. You can think of something like that. If these two information are linked properly in the metadata, then SMK will automatically open DMK. You don't need to open DMK, and you can straight away start opening from the certificate or symmetry key, and then start encrypting the data and decrypting the data. Basically, you got to open the DMK. So how are you going to open? There are two ways that Microsoft has specified: SMK or by password. You can say, I don't want to open by SMK. I don't want DMK to be encrypted by SMK. Remove this record. Okay, you can say that. There is a command, alter DMK, remove, delete encryption or remove encryption. Something is there. Okay, you remove encryption by SMK. That way, you are saying you don't want open automatically by SMK. There is only one way to open DMK is by password. You must have to specify password. But SMK encryption is optional. By default, it gets created. It's easy and convenient, right? You don't need to open the DMK, but you have option to remove that as well. Okay, that flexibility is there. So that is why it can be decrypted. If you know the SMK, you can decrypt, you can open. If you know the password, yeah, you can. That's why you see the two records here. So anything else in this metadata, catalog views, nothing, right? So we just created the database master key. And then the next step is we have to create the certificate. The reason I told you how you generally encrypt the column, you have to use this path: SMK, DMK, certificate, symmetry key, and data, right? So we just created the DMK. Our next step is to create the certificate and then create the symmetry keys. That is what this statement says: create the certificate. Certificate is type of asymmetric key. It needs to have private key, right? And then this is self signed certificate. Okay, this certificate has not been provided by any third-party company or module or anything like that, any hardware or anything like that. SQL Server, you can create self-signed, certificate. So certificate is certificate. It has a private key. Private key is protected by DMK. All right, now let's create the certificate. Now I'm going to execute this catalog views just to show you what are the things that gets created. So you will see that here sys certificates, you will see one record. It shows that this is a certificate encrypted by database master key. Okay, that's what it says. And this certificate expires. There is expiry date. Expiry date 4/29, 1 year right from now. Okay, so if you don't specify expiry date, it expires by 4/29. Doesn't mean that you cannot use the certificate, but things will, it will keep working. Whatever the symmetric key, asymmetric key, that gets protected by the certificate. If it's already expired, that will still keep working. But there are some situations where it doesn't work because the expiry date. Okay, expiry date, you didn't specify expiry date, you just created a certificate without an expiry date. So how can you specify, there is an option, expiry. If you specify expiry date equal to some 2050 or 70, then you can still use the certificate. But then why 1 year? See, generally, if you need to do the key rotation, you cannot, it's like a password. Do you keep the same password forever? No, right? Every month or 2 months you change the password. That means you are doing the password rotation, something like that. In SQL Server, the keys, you have to rotate them. You have to rotate the, the keys. You have to change the expiry date or passwords or whatever it is. You have to rotate the keys, right? So you got to change the certificate altogether to different certificate. For example, see, now I have to, now to encrypt the data, I create a symmetric key 1, certificate 1, DMK 1, things like that. I'm just saying, for example. And after 1 month, you wanted to use a different certificate, not certificate 1, certificate 2 you wanted to use, because you want to rotate the certificate, right? For better security, right? So then what you do, you create a certificate 2, a new certificate, and then you alter the symmetric key to use the certificate 2 instead of certificate 1. That's it. That's how you rotate the certificates. So that is why Microsoft, I think might have decided, oh, keeping 1 year might be, too long, probably a best bet, probably you might be rotating, monthly or once in 2 months, but having the expiry date 1 year is, they're giving too much leverage for you, hey, you are giving 1 year time for you to rotate, so that is something you may have to make a note of it. But this is a record that gets created when you create the certificate. Okay, so our next step is to create the symmetric key. You can see here, create symmetric key, the symmetric key name, whatever the algorithm that I wanted to use, DES, triple DES, AES 128, 256, 192. There are plenty of things, but this is the default better one. I think a lot of people suggest and uses this one. So you can use this algorithm and encryption by certificate, test certificate. You can see that here, this automatically protected by DMK, and this certificate, the symmetric key is, you have to say encryption by certificate, this certificate, right? You can say encryption by password, right? You can also say that. That means here you are saying, okay, instead of certificate, instead of protected by certificate, you can say protected by password. Okay, that means you don't need certificate or DMK, whatever the stuff, in order to encrypt the data. All you need is just a password to open the symmetric key and then encrypt the data. To decrypt the data, again you need a password to open the symmetric to decrypt the data. You don't need any of the certificate or database master key, asymmetric, whatever, blah blah blah. You don't need any of the stuff. Then you got to say encryption by password. You got to write that code, the password in the application, in the TSQL, stored procedures, and then application. So it's not safe to just keep spraying the password all over the place. Then it is not safe and secure. So this is how generally you do, create symmetric key. Let's execute. Now let's go back to this catalog views just to see what gets created. Now you can see I created test symmetric key, and then the test symmetric key ID starts from 256, not 102. I don't know why, but when you create a symmetric key, it gets created from 256. We selected algorithm, and then the password. No, it is not certificate, right? Yeah. So now 256, the symmetric key ID, you can see it is protected by certificate, right? You need to open the certificate. You need to have the certificate to open the symmetric key. That's it. If you don't have certificate, you don't have access to certificate, that's it. You cannot decrypt the symmetric key, and then as a result, you cannot decrypt the data. So you need to have the certificate. That's the only way to open that symmetric key. That's what this table says, right? Now, you got to open here in this demo. I'm going to show you how to decrypt a column. Okay, I'm going to create a table next, and I'm going to encrypt the table, encrypt a couple of columns in the table. This is the setup I got to do before that. Okay, so now I created all the necessary keys in my hierarchy to properly encrypt the column. Now it's time to encrypt the column. Open the symmetry key. I say open the symmetry key, decryption by certificate. Now let's open the key. Now there is one catalog view sys.open keys that will show you what are the keys that are open. So here it says the database name is a test and the key ID 256 we just opened, right? This is the key GUID. So it shows, okay, is it a valid key? Of course, it's a valid key, otherwise we cannot open, right? I don't know in which situation it changes, but whatever I have seen, the status is one that means valid key. All right, now let's create a table. And this table has customer name, plain text, varchar, and then the encrypted text, var binary. The encrypted data should be, must be stored in var binary column. Okay, binary column. Okay, that's where the encrypted data. So it must have to be binary column. Var binary is just a variation of binary, right? So this is where you store the encrypted. So what I'm going to show is I'm going to write this plain text, and I'm going to use the same text. I'm going to encrypt the same value. I'm going to insert this value in plain text, and I'm going to encrypt this value 1 and put it in this encrypted text. Okay, so to encrypt by key, I have to specify what is the key I'm going to use. Okay, I can use any key. In this scenario, I just created one symmetric key, that's it, and I just opened that symmetric key. And you have to open the symmetric key to insert, right? You have to open the symmetric key, and to open you have to open all the all the certificate keys that are in the chain. So you have to open the symmetric key, and then you have to encrypt by that key. So that's what the statement does. So did I create this table? Yes, I already created. Now let's insert the records. Okay, so I inserted 3 rows. Now let's close the symmetric key. Now let's check if any keys are open. There are no keys are open, right? So here I just want to tell you one thing. You say encrypted by key, you have to tell the symmetric key, and there is a function called GUID. Why you have to say GUID? See, what happens when you encrypt the data, it encrypts the value 1. Okay, so it encrypted value of this text, value 1, right? That's what you think normally, okay, so I'm going to encrypt the text, whatever the text I'm going to encrypt. So this is the value 1 I'm going to encrypt and write it into the column. No, it is also not only this encrypted value, this function, what it does is it encrypts this and it writes the GUID of the symmetric key as well. That encrypted key contains the several pieces of information. I'll show you next couple of minutes. So this is how I encrypt a column, right? These are the things I have to do. That's it. Now to decrypt the column, I have to use a decrypt by key function. So first I have to say open the symmetric key. I can open and then check the open keys, and then this is how I decrypt. See, I have to use decrypt by key and whatever the column, the encrypted column, that's it. To encrypt, I have to specify which key I wanted to use to encrypt. While decrypt, I don't need to specify which column to decrypt, right? So I said, okay, show me the decrypted column. So this is what the select star, I said these are the 3 columns. This is the last column, decrypted value. I successfully decrypted value 1, 2, 3. This is what I encrypted, right? I successfully decrypted it. I didn't specify use the symmetric key, right? So if I close the symmetric key and then okay, say open, show me the open keys, no open keys, right? So now if I execute this query, what happens? It cannot decrypt because the symmetric key is closed and I cannot decrypt. So whenever it cannot decrypt, it will show null values. Null values means you don't have access, or you didn't open the right keys to decrypt the data. That's why it shows null. Okay, so then you got to figure out why it didn't decrypt. So sorry, why it didn't open. So what is wrong, right? So now let's do a couple of things. I'll show you few things to encrypt. So far what we have did, we have created one symmetric key, and then we have used that symmetric key to encrypt the value 1 and write the encrypted record, encrypted data in this encrypted text, right? That's what we did. So we just created one, but now we are going to create another certificate. Okay, the new certificate, and then the new certificate, and we are going to create symmetric key, test symmetric key based on the new certificate. That is fine. And then open the second certificate, and then now this time you check how many open keys I have. I just have one symmetric key, set symmetric key 2, that is open. Now I'm going to use the second symmetric key to encrypt the data. Here what I have done, I use the first symmetric key to encrypt a couple of records, right? But here I'm going to use the second symmetric key to encrypt few more records. So the same table you can encrypt with multiple certificates, and you can store it in the same table. That's what I wanted to show you here. So now I'm going to execute these records. Okay, I inserted 3 more. Close this certificate. Check the open keys, nothing. Okay, now you select from the encrypted table. If you see here, okay, let me show you. Let's execute this one. So key name, there is one function. Basically what this function it says is, show me the keys, in this case symmetric key. Okay, so you can use asymmetric key or certificate to encrypt the data. Show me the key that is used to encrypt the data. So if you see here, these are the keys I used. First 3 rows I used symmetric key, and the next 3 rows I used symmetric key 2. I cannot decrypt the records because there are no keys open, right? I cannot decrypt, but I can see what are the keys that I have used to encrypt the data, right? So how does it know? Because the thing I told you, this is the symmetric key GUID. I just wanted to show you. Let me show you the other piece of information. Okay, now I'm going to open the 2 keys, and you can see that the 2 keys are open. Now let's select it. Okay, so when I execute decrypt by key, I have to specify the column name. That's it. I don't need to specify symmetric key. But whatever the symmetric key, it knows what symmetric key based on the information in the database. But you need to open that before you execute this query. I know that I have encrypted 3 rows symmetric key 1, 3 rows symmetric key 2. That's why I open these 2 symmetric keys, and then when I execute this query, it properly decrypted, right? I just want to show you that. Now when I close, okay, I cannot now decrypt because it's closed. Okay, so I have some more examples to show you. Let me so let's execute this query. So here what I'm doing is I am selecting the 2 symmetric keys from the catalog views. So you can see that here, select star from symmetric keys. Of course, database master key I don't want to see. That's why I eliminated that. Here you can see the 2 rows here, the key GUID values. These are the GUID values for the symmetric key. Okay, so and then I said in this statement, I said, show me the GUID values of these of the two symmetric keys. And then this statement, if you see here, what I'm doing is I'm selecting the GUID value. So here, if you look at these two statements, I'm taking the two GUIDs manually, and then I'm looking at what is that value here. Okay, so this statement, this is the key GUID statement, because this is the one you use to encrypt. See here, you use to encrypt the key GUID value. So basically what you are doing is you are using that symmetric key GUID value and you are inserting along with the encrypted data. Whatever the data that you are encrypting, this value 4, you are encrypting this data, you are combining this data with the key GUID. That is why I wanted to manually check. Okay, so what is the key GUID from this? Okay, these are the two GUID, and then you can see that those values here, right? These two values here, F4FCE, you can see here F4FCE here. Okay, so first three has the symmetric key GUID, and the next three has F4. Okay, so the other one BE440. Okay, BE4E0. Okay, so you can see that here BE4E0. Okay, so this is the encrypted data. Encrypted data has multiple pieces of information. So in one of the screens here, I wanted to show you the encrypted data has the GUID of symmetric key, 16 bytes, and then the encrypted data here. And there are other pieces of information, version number and random initialization vector. And when you decrypt the data has a lot of details, right? What is the symmetric key that I'm going to use? What is encrypted data? And a lot of things. So you don't need to specify, you don't need to pass any symmetric key to the decrypt. Hey, I already know it, right? So all you need to do is just open that symmetric key. Just make sure you open. You don't open the key, I'm not going to show you that record. That is what I wanted to show you here. Next thing is, see here, and then you here what I'm doing is, do I have any open keys right now? No open keys, right? So I don't have any open keys. If I execute this line, see, you have to open the key, symmetric key, to decrypt the data, right? That is what you did so far. Open the symmetric key and then decrypt the data. You don't need to open manually. Decrypt by key auto certificate. That means this function is open the symmetric key automatically and then decrypt the data. That's what this function is. Decrypt by key, automatic certification, and this is a certificate. If you use this function, you don't need to see, I can decrypt the value here, right? That shows that I don't need to open the key manually. And similarly, see, the first three records, I have to specify just one key, right? I had to specify one symmetric key. That is why I couldn't show you the three records. But if I use this certificate, the second certificate, you can see here, I can show you the three, but I can't show you the first three because you can specify multiple certificates in this function. Then I was thinking, so what happens if I select this one? It's kind of showing some weird, but it shows details, value 1 to 4. But you can see here, it shows null here. So, something weird happens. Basically, it automatically opens, and once it opens, I don't know, it's showing values a little differently, but you don't want to use this, combining these two. When you are decrypting a column, you can use case function. Okay, if the first GUID equal to this symmetric key, then use this decrypt by key function, decrypt by auto key function, this function to decrypt the data, right? You got to use some case logic to show the data properly if you are encrypting by multiple symmetric keys and storing it in the same column. Okay, this is another example I wanted to show you. Right now you have one table and encrypted data. can you copy this encrypted data into another table and browse it? Or is this encrypted data so specifically attached to this table? For example, if you copy this information to another table, will it work? That's what I wanted to trying. Here what I'm doing is, okay, there is a select star into encrypted table backup, another table. I'm just copying this data into another table. All right. Now I'm opening the two certificates because this table has encrypted data based on the two certificates. So I got to open the two certificates. Now I am using select star from that backup table. I can open, right? All I need to do is just open the two keys, and then I can decrypt the data. I can, this is from the backup table I just created, right? So that means you can copy encrypted data into other table and start browsing, start decrypting and do whatever it is, right? That's what it says. Okay, let's take another example. Okay, there is something called, see, the reason why I wanted to show you this example, if somebody copy the encrypted data from one table to other table, they get the details. So that encrypted data, whatever the encrypted data in this table, it is not attached to this specific table. Okay, you simply cannot copy this data into another table and browse them and decrypt the data. If you're concerned about it, then you need to use authenticators. There is something called authenticator. You have to use this. So what it means is, let me copy this. Okay, let's show this. Let's execute this line. See, this record is not attached to this one. So for example, let us say this plain text. This is some, let's say this is some account balance table in a bank. Okay, this user has $100 in the bank account. This user has $1 million in the bank account. So you cannot simply copy this record, right? You cannot simply copy and paste here. If you copy and paste, then this user will have $1 million in the bank balance. So because this 1 million is not so really attached to this user. That is what I've shown you earlier. I can simply copy this encrypted data in another table and I can decrypt the data. I can get data back, right? So this is not attached to anybody. As long as you open the key, anybody can use this encrypted data. Why you have to copy this into another table? So for example, if a bad actor is there, and what he does is, I know that user 3 has $1 million in bank balance. User 1 has just $1. Let's copy this information into this row. That's it. That's all you need to do, right? You don't need to know the value $1 million. You can simply, that somebody has $1 million. Just copy that value here. That's it. There is something called Authenticator. What it does is, now you are encrypting this data, right? This is encrypted data of $1 million. This piece of information shows, okay, this is the symmetric key, first 16 bytes, and then there is something, and final there is some piece of information here which says $1 million here, right? So not only that, you have to add another information here, tie this record to this user. For example, you encrypt the value user 13 here. Okay, so let's say this is the encrypted value here, right? This is that GUID value. For example, this is the GUID, and this is some version number I just showed you earlier, right? This is the version number, the random initialization vector number. I don't know what these two things are. Seriously, okay, I know the GUID, I know the encrypted data because that is the value I wanted to encrypt. These are the things here, right? All these things. I also wanted to encrypt, because this record, I also wanted to encrypt user 3. For example, let's say this is that number. Okay, this is that value. Okay, let's say user 3, and put that user 3 encrypted data here. Then my encrypted column becomes like this. It consists of 1, 2, 3, 4, 5. Fifth piece of information, the fifth piece of information is user 3, because I want this record is specific to user 3. In order to decrypt that record, I need to open the symmetric key. I also need to pass this user 3, this value, to decrypt this record. If I simply copy this information, paste it here, I cannot simply open the symmetric key and decrypt the record. Then I also have to pass the customer number, right? But I cannot pass customer user 1 because I got to pass user 3. That is the value. This value is that is the value. I got to open the symmetric key and I got to pass the user 3 in order to open this record, in order to decrypt this record. Simply I cannot copy this. That is what you are tying this. That means you are encrypting with some other column just to make sure that this value is really tied to this user 3. Okay, that is what authenticator means. I am adding one more column, for example, unique ID. You can see that here. Okay, open the two certificates. And then let's select the data. Since I opened the two certificates, I can see all the records, right? And then here what I am doing is I am updating the sixth value, whatever the sixth value. What I'm doing is I'm copying this record from the user 6 into user 3. That is what I'm doing. I'm copying here, I'm copying and paste it here. Okay, that's what I'm doing in this update statement. Okay, now let's select the table again. Now you can see, okay, now it's no more value 3, it's value 6. I was able to successfully decrypt for user 3, right? Now, I don't know what the value it is. I just simply copied and I'm able to show that user 3 has value 6, not value 3. Okay, now let's insert another new row. I have created another column, unique GUID. So I'm generating the new ID value for that, unique GUID value for that new column here. So I just inserted one value into this table. Now if I select, okay, so this is what it is. Okay, so this GUID. So what I'm trying to do here is I'm going to attach. See here what I did. Encrypted by key. I used symmetric key, whichever the key I wanted to use to encrypt the data, and what is the value that I am going to encrypt, and I'm going to add authenticator value. That means additional value, and this is how I specify. I said, okay, so I'm going to use the unique ID, some different value to add, right? That's authenticator value. I have to store that unique ID in the database as well, because when you are decrypting, how do you pass this value? How do you know this value, right? That's why to decrypt this record, I am going to use this unique ID to decrypt this record. Okay, so if I am copying this column, this value into this column, I also have to copy this unique ID value there. I cannot simply copy this because this is combination of many things, including this unique ID. So I got to copy this, then I can use this unique ID. It is the additional way of protecting the data, nothing more than that. I just wanted to show you that there is something more in the column level encryption authenticator that you can use in order to avoid malicious data copying processes, this type of things. So now I have inserted. Now if I select this table, I get this. Now I'm updating user 3 with value 7. Okay, so now user 3 here, you can see. Now I'm going to copy this to this record. Okay, I just did it. Now if I say select this table, I cannot, for column 3, you can see that I cannot do this. Okay, so earlier I was able to show value 3 because now it is, you can simply see that here I copied this record here, and I'm simply decrypting that column without specifying any authenticator. See here, I'm saying decrypt by key. That's it. I didn't pass any additional authenticator. So that is why, okay, if I execute this query and pass authenticator and pass the authenticator, then I can successfully decrypt the value 7 because I don't, for this record, there is no unique ID. Okay, so because I didn't copy this information, that's why I couldn't decrypt that value. Close the symmetric keys. So that's what I wanted to show you. There is something called authenticator, additional security protection. So this is how you encrypt the column. And not only that, you have you can encrypt the column based on the passphrase. Let's test this one as well since we are here. So here I'm creating a table and then I'm inserting this is the data. Here I am going to encrypt hello world. This is the value that I'm going to encrypt. This is the key I'm going to use to encrypt the data. Okay, so this key is not one word, it is multiple words. That's why you call it as a passphrase. Otherwise, it would be password, right? You can write any number of words. Okay, you can write poems or whatever the stuff. You insert rows and then select star from decrypted. You can see that it's decrypted, and then you can say decrypt by passphrase. You can use this function and then use the right key, whatever the key that you used, whatever the passphrase you used to encrypt. You got to use the same passphrase to decrypt this column, and then you can decrypt the value. So this is one way of encrypting. But you got to spill this passphrase all over the place. Then that is not a safe at all, right? But there is another way. If you don't want to create, say, symmetric keys or asymmetric key, all this nonsense, then you can simply use passphrase. Hey, go easy. There is one way of doing it. So that's what the column level encryption means.